Hi, my name is Satya, and this is about a machine learning project. The area of the project is supply chain and specific to US. We know that an item produced at a location reaches either to a location or multiple locations. These items reach their destinations through different mode of transportation: road, rail, air, or water. There are multiple variety of goods that are shipped. If the origin location is closed due to a particular reason, and that could be pandemic, for example, then not only that area but the areas that receive the goods are also affected. Particularly, situation would be severe if the goods are medical related. Here we try to make machine learn the movement of freights between locations along with other features, and then it should be able to predict if closure of a particular area or metro would be critical. For the project, the data regarding shipments is obtained from kaggle.com website. This census data belong to 2012. Let us quickly go through the columns of the survey. I will try to point out any key fact regarding that column as I go. Shipment ID is a unique number that is supposed to run through the records incrementally. Nothing special about it. Origin state is a location where the shipment is manufactured. The value here is a numeric code that uniquely represents a state. The example given here is 24. Along with survey data, the lookup list for these codes is also given. Origin MA field consists code representing a metro area within a state. Origin CFS area is just a combination of state and metro is combined with a hyphen. Fields destination state, destination MA, and destination CFS area are similar to origin fields except that they are destination location for that shipment. NAICS again contains code for shipper classification. Here the sample code 311 represents food. Quarter is a no-brainer. It represents the quarter of the year to which the shipment detail belongs to. SCTG is two-digit code for commodity, and this is important to us as we are going to filter medical shipments using this field. Here 35 represents electronics. Mode contains code for transportation. Again, shipment weight is the weight of the shipment in pounds. So here we have a variety of values starting from 0 to a big value. We'll talk about it in next sections on how it is handled. Next two columns relate to distance. Temperature control, yes or no, is self-explanatory. Then next two columns are regarding export related. Hazmat column has hazmat code if it's a hazmat. The last column is shipment tabulation weighting factor, and according to census, it is a product of 7 different component weights. Okay, there are 4,547,000 records in the dataset. As part of EDA, verified and studied columns as per below mentioned points. In the survey, did not see null values in the prime columns. Duplicate entries were less. Weight was the one of special interest while checking with plot distribution. Care has to be taken for the same. Categorical data turned to be good. Quarter column was the one that was analyzed for time series. Correlation between features was checked too with mixed results. After study of data on first pass, the features with which experiments can be initiated are origin CFS area, destination CFS area, quarter, SCTG, and mode. Importantly, the presumption adopted was that our origin is to be categorized as critical if it supplies commodity to more than 100 locations, or if it produces more than 1,000 tons in a quarter. Identified are origin metro area, destination metro area, quarter, commodity type, and transport mode. The target variable or dependent variable is a classifier that is critical flag. We use the value 1 for critical and 0 for non-critical. So looking at the nature of data and variables involved, the machine learning model, the nearest it should be tried with is logistic regression model. The sigmoid function shown here is specific to multi-independent variables. Also, the derivative equation is shown here that is used during implementation. After implementing the model with the said equation in Python, The program was experimented with various combinations of features and settings. The results were compared with using confusion metrics. An important point to note is that the input columns from dataset were regularized and columns given to model are origin, destination count, weight, mode of transportation, quarter, and critical flag. In terms of database, the records from original dataset were grouped on origin, mode, and quarter. Destinations were counted, and weight were added up. This grouping brought the final record count to 1380 for the model to learn and test. During experiments, regularization and feature scaling of data was tried on weight, as this column has null, that is zero value, and also very high exponential values compared to the rest. Now let us look at the results. The model was tried with various combination of features. When the results were compared, the best results that were obtained and also looked reasonable were with origin, destination, weight, and quarter. The average accuracy was around 81%. It was observed that when mode of transport was involved, the statistics showed poor numbers. It looked the data was biased more towards road. Statistics from one of the experiments are shown here. The data was broken into 80% to 20 for learning and testing. Would like the precision and F1 score to be around 1. Confusion metrics was the primary tool that was used to compare the results. Here is some discussion on observations and difficulties faced. The model after implementation was run numerous times. The results produced were very much inconsistent. I suppose all possible settings that can be done programmatically were applied. It looks more work to be done at data level. Initially, because of the data set size, the machine configuration I had was not enough to experiment with. It took a while to get things in line for running the model. Even though this experiment was done with medical related shipments, I would like to experiment with other commodities like food, which are also vital in case of pandemic. The data provided was quarter-wise, and if was given monthly-wise, the experiments would have probably given better results. This is due to the fact that there definitely would have been a seasonal effect on freight movement. Again, to summarize, the purpose of this study was to understand from where medical items are being produced and to which locations it is being supplied to. And will the impact be critical if a location is closed due to pandemic? The model implemented learns the dependency of various locations on the supply of medical goods through different transport modes and then predicts criticality. I'm confident if present shipment data is fed to this machine learning system, it will be a useful system in determining criticality of closures. Nevertheless, there is still scope for experimentation to be done with the dataset. On top, this project has provided me opportunity to learn hands-on with practical data. Thank you for listening. Bye.